This video will be talking about concentration of solutions. So it's a big word, isn't it? And the key to concentration is we're going to talk about the amount of solute usually divided by the amount of solution. Sometimes we'll be talking about the amount of the solvent only. So key thing to remember is that the solution is the solute plus the solvent together. Okay, so we're just going to talk about different sorts of units that can be used for the amount. You can use grams or moles or volume. Okay, and you can use any combination of that for the numerator or the denominator. Now, so you can figure out there's like 9 different combinations, but only a few of them are important. One is the weight percent, where you have grams divided by grams. Another is volume percent, which they use for alcoholic beverages. That's volume divided by volume. And then the most important one we're going to talk about is moles per liter of solution. The liters of solution might be something we could measure with a cylinder or a beaker or pipette. And of course, moles is a fundamental counting quantity for the amount of a substance. Okay, so let's do a simple example. We're going to ask if we have 0.50 liters of solution and we dissolve 6.0 grams of sodium hydroxide, then what is the concentration of this solution? Now, so the appropriate unit we're going to talk about is molarity. Okay, so molarity is abbreviated by capital M. So let me spell it. A lot of these words have very similar spelling. All right, so it's not morality, it's molarity. And that is moles of solute divided by liters of solution. And we can already see that we have the volume solution, so all we have to do is find out what is the moles of sodium hydroxide. Okay, and so the answer is quite simple. We convert 6 grams of sodium hydroxide using the molar mass. Which is 40 grams per mole. And always write grams of what you're talking about and moles of what you're talking about. And grams divided by grams cancels the unit of grams. Now we have moles of sodium hydroxide. So it's a very simple calculation. All right. So 6 divided by 40 is 0.15. Mole sodium hydroxide. And so the molarity is not 6 grams. It is 0.15 moles. Of sodium hydroxide divided by 0.5 liters. And that is 0.30 molar sodium hydroxide. All right, so this is the common way to actually write it, is the moles of the solute per liters of solution. Then you use the capital M for the units, moles per liter, and then you actually write down the solute formula after the capital M. So this is how you would exactly make 0.3 molar sodium hydroxide. So somebody would give you instructions, okay, take a half a liter water, well, nearly a half liter of water, because if you add sodium hydroxide, it might go above half a liter. So you want to say maybe 0.4 liters, dissolve sodium hydroxide, and then top it off to water to 0.5 liters. All right, so let's look at another important unit, and that'd be weight percent. Okay, so let's look at sodium hydroxide and water again, but this time we're going to use some different units in different quantities. Okay, so let's see, weight percent. Okay, let's mix, all right, 30 grams of sodium hydroxide. And 120 grams of water. Now, the first thing you have to know is the total amount is 150 grams of solution, because the weights of the two individual components will simply add up to the total weight of the solution. And so the weight percent is simply the percent of 30 out of 150. Okay? The percent of one part, the solute, divided by the all parts. All right, so 30, the weight percent is going to be 30 divided by 150. Of course, and convert it to a percent, you multiply it by 100. And so 30 out of 150 is 20%. So whenever you see percent in a solution, but without saying exactly what the unit is, if it's grams or moles or volume, assume grams unless you're told otherwise. Okay, so a lot of the times they won't say weight percent, they'll just say percent. All right, so finally let's do a volume percent, which is what they would use for alcoholic beverages. So let's see. Let's say we mix 50.0 mils of ethanol and 50 mils of water. Okay, and so this would be the strength of a typical bourbon. Most distilled spirits are probably 80 proof, which is 40%, or 100 proof, which is about 50%. And so, so the total volume is 100 mils. And so the volume percent, which is usually written as volume divided by volume. Okay, so you'll see a percent V over V, and this would be 50 divided by 100 times 100%. Of course, it's an easy calculation to do, and that would be 50% alcohol. Okay, so one of the interesting little quirks about this is that when you calculate percent alcohol, if you do it by volume percent, then you get a much larger number than if you do it by weight percent, because volume weighs less than water on a volume basis. That is, say, alcohol is less dense than water. And so a 6% beer, you may ask yourself, is that volume percent or is that weight percent? Well, if it's weight percent, it's like 7-something volume percent. And so most of the laws are written about percent alcohol are based on volume percents.